problem 17, 98, maximum number of consecutive values you can make. So for this problem, we are given an array of coils. So for example, we're gonna have a coils of 1 and 3. So the length is n. It's gonna represent n coils that we can own. So the value of the ith coil is coils I. You can make some value x if you can choose some of your n coils such that their values sum up to x. So what is the meaning? So for example, we have coils of 1 and 3. Yeah, we can choose some of the coils to make up some values, so sum up the coils. So for example, from the beginning, we're gonna have use a 0 because the final return gonna starting from 0. This means we didn't choose any coil. And if we choose a coil of 1, this means the range is gonna be from 0 to 1. But for the next, if we were to choose a value of 3, because definitely we don't have a value of 2. So if we choose a 3, so the value is going to become 0 plus 3, 1 plus 3. So it's going to become 3 to 4, right? But this means the value of 2 is missing. Yeah. So if the 2 is missing, this means, yeah, the longest range for us is going to be 2, because we're going to return the maximum number of consecutive integers. So it's going to be 2, because this 2 is missing. It is not consecutive. But for the second example, as we can say 1, 1, 1, 4, definitely it can become 1 to 0 to 8. Yeah, so this is a 0. If we choose a 1, it is 1. What about if we choose the next one? It's going to become 0, 1, 2. So what about if we choose the next one? It's going to become 0, 1, 2, 3. Yeah. So now we have a value of 4. So 0 plus 4 is going to be 4. 3 plus 4. Yeah, it's going to be 7. So it's going to be 0, 1, 2, 3 until 7. So how many coils? It's going to be 8. Yeah, so 7 minus 0 plus 1, definitely it's going to be 8 coils. Yeah. But how can we solve this problem easily? First of all, if we were to find the maximum number of consecutive numbers, so the easiest idea and the straightforward idea is we're going to sort the coils array first. And this is the greedy idea. If we sort the array, like the example what is given, so definitely this means, we can keep, because if we sort the array, because we're gonna always have the smaller number first, it means we can always, build a longer consecutive range. So for example, let's just use 1 and 4. And let's just use 1 and 2. Maybe it's a better example. 1 and 2. So if we have a number of 1 and 2, definitely we can let it become a range of 0 to 3. Yeah, so this is the previous example. Now, if it is not sorted, it is 2 to 1. What's going to happen? First of all, we don't have a coil of 1, because currently we are checking this coil 2, and there's no 1. So definitely there's no consecutive numbers. There's going to only be 1, which is 0, because there's no 1. So the length is 1. But in this example, the length is 0 to 3, the length is 4. Yeah, so this is the longest. So this is the greedy idea. We have to sort the coils array first. Yeah. So the second idea is that we're going to use some examples. So for example, currently we have a 0, 1, 2. So this means, currently if we have a range of 0 to 2, so this means we have a valid range from 0 to 2. It is valid. Now, what's going to happen for the next coil? If we have a coil of 1, definitely the final result is going to be 1 plus 0, 2 plus 1. It's going to be 0 to 3. Yeah. What if we have a value of 2? It's going to become 0 plus 2, 2 plus 2. It's going to be 2 to 4. This is 0 to 2. Definitely we have a range of 0 to 4. Yeah. Now, what happens if we have a value of 3? So similarly, we're going to have a range of 0 to 5. Yeah. So what happens if we have a value of 4? Yeah. So here the strange thing happens, because this range is 0 to 2. Now we're going to plus a 4. It's going to be 4 to 6. Yeah. So 0 plus 4 is going to become 4. And 2 plus 4 is going to become 6. So it means here is 4 to 6. Here is 0 to 2. And 3 is missing. So definitely it is not the longest. Definitely if we have a value of 4, it means we're going to break it from here. Yeah, so the longest range is still 0 to 2, which is going to be 3. Yeah. So this is how we're going to solve the problem. Yeah. we're gonna always check the coins one by one, and this coin has already been sorted. So if there's a bigger gap, we're gonna stop it. If the gap is smaller, we're gonna continue. But how can we control this gap? We're gonna set a variable s. From the beginning, it's gonna be starting from 1. So this means we're gonna have a range from 0 to s minus 1. So this means from the beginning, the range is just 0 to 0. Yeah. So this is very important for the setting. We're gonna set s equal to 1. This means the range gonna always be from 0 to s minus 1. Yeah. Now we have a coin of 1. What's gonna happen for this one? So this means the range is gonna be updated to 0 to 1, right? Because 1 plus 0, 1, 0 plus 1, it is 1. So it means from 0 to 1. So this is the new range. But what's going to happen for this s? S is going to become 2 because s is going to plus this value, which is 1. So s is going to equal to 2, and the range is 0 to s minus 1, which is 0 to 1. Yeah. Now what's going to happen for the next? Because for the next, the number is 3. This number is more than s. Because it is more than s, so what we can do? We just need to break out the while loop. Yeah. So the while loop is we're gonna use s. Yeah. Let me think about the while loop. I'm gonna use s to less than and equal to a target number, and I don't know the target number, but what could be the final target number, and what could be the maximum target number? It's going to be sum of the coins. So for example, in this example, the target value might be 7. Yeah. No. Let me think about it. Yeah. So what's going to be the target value? Yeah, so definitely it's gonna be a really big number. So yeah, we can set a target value to sum of the values of the coins. Yeah, we can set it sum value of sum of the coins to be a target. Yeah, so for this example, we're gonna set a target to 7. Yeah, but let's just start coding. I think we can solve it later on maybe. So we're gonna prepare s gonna equal to 1. First of all, we're gonna sort the coins array. So we're gonna sort the array, and we're gonna set s equal to 1, I for coins, and result for final result. Yeah. Now we're gonna use a while loop to check. So I'm gonna use s to less than and equal to a target. So this target is gonna be a maximum value. So this max value gonna be sum of the coins. Yeah, I think it should be the sum of the coins. Although there's a little bit calculation, let's just check. The coin size is 4 times 10 to the power of 4. Yeah, so this means inside of the coins. Yeah, so I'm gonna use sum of the coins as a target value. So this means if it is inside of the range, definitely it is possible. Yeah, because for me, I don't need to add any number inside of the coins. I just need to use all the coins. So if I were to use all the coins, so what's gonna be the possible result? Yeah, so the possible result definitely is gonna be the sum of the coins. Yeah, it means every number is possible. So in this example, the sum of the coins is 7, and 7 is also possible. So the maximum possible value, I'm gonna set a max, gonna be equal to sum of the coins. Yeah. Now we can start the normal case. So if I less than length of the coins, and s and the current coins is less than and equal to s. So we're gonna update the s with this coins. S gonna plus equal to coins and I gonna plus equal to 1. Else it means it is not possible, so I can break it immediately. So finally I need to return. Let me think about it. Finally I need to return s. Yeah, because our range is from 0 to s minus 1. So how many numbers it's gonna be s? Yeah. Now let me just run it. As you can see, it works. Yeah. Now let me just submit it to check if it can pass. Yeah, as you can see, it passed for all testing cases, and it's pretty fast. And the time complexity is n log n because we used a sorting. Yeah, I think the difficult part to understand is why we're gonna set the s equal to 1, and why we're gonna set the s less than or equal to maximum number, max, and this max is gonna sum of the coins. Yeah, because we cannot add any coins inside the array. Definitely we're gonna take use of all the coins. If we can use all of the coins, so that means definitely it's gonna be a maximum target number. Yeah, it's gonna be the maximum possible number. Yeah, but from here, while we are checking, if it not happens, definitely we're gonna break it. Yeah, if you don't want to use the maximum number, maybe you're gonna use this number. 4 times 10 to the power of 4 and times this n. It's going to be 16 times 10 to the power of 8. It's going to be a really big number. It's going to be this number. 16 times 10 to the power of 8. Definitely this is a really big number. We don't want to have that kind of big number. Yeah. I think it also works because it's gonna be really fast because it is log this number. That is why it still work. But we don't want to use that big number. We want to make it a smaller number. So we're gonna use a max. Yeah, it's gonna be sum of the coins. Yeah, I think that's all for it. Thank you for watching.